Hello everyone, this is Mayuk Mazumdar and I'm back with another exciting session. So let's proceed.
As promised, today I'm going to dig more into coding section. So for every developer out there or those who are new to programming, so we all must be aware of this Fibonacci series. If not, brothers and sisters, this is one of the very basic series that is being taught while one learns coding. At least for me it has been in any language, maybe Java, C or Python or C#. Wherever it was, I was taught this series at the early stages. So, and over here you can get to see my cheat sheet. So I have come well prepared so that I do not fall into any other trap of forgetting or doing some mistakes. So I'm ready with my cheat sheet. So beginning with Fibonacci series, the basic of the examples. So what it does is, with this script I'll be printing the Fibonacci series. So before that, let me say you what a Fibonacci series is. So it's, if I start with 0 and then the first two elements are 0 and 1, if it is, so the third element is 0 plus 1, that's 1, and the fourth element is 1 plus 1, 2, then the fifth element is 2 plus 1, 3, then the fifth 0 1 2 3 4, then the sixth element is 3 plus 2 5, then the seventh element is 5 plus 3 8. So as you get to see, the sum of the earlier two elements forms the next element of the Fibonacci series. So this is the definition of a Fibonacci series. So for that, what I'm doing, I'm assigning two variables a comma b to 0 and 1. Then I'm checking using a while loop to check that while a's value is less than 10. So I'm printing a, otherwise I'm assigning a comma b equal to b comma a plus b. So that's a magical part over here. I'll be describing each part of the section. So for that, let me run it and show it to you, the output first. Okay, so what you get to see, 0 1 1 2 3 5 8. As I said, 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8. So these are the first elements, first 8 elements, 1 2 3 4 5 6 7. Yeah, first 7 elements of a Fibonacci series. So what this code snippet does, the first line contains a multiple assignment, that is, the variable a and b simultaneously gets assigned to values 0 and 1. On the last line, this is used again, demonstrating that the expression on the right hand side are all evaluated first before any of the assignments take place. The right hand side expressions are evaluated from left to right. Okay, so now I have this while loop. The while loop is a checking purpose. This while loop executes as long as the condition, here a is less than 10, remains true. In Python, like in C, any non-zero integer value is true, a 0 is false. The condition may also be a string or list value. In fact, any sequence, anything with a non-zero length is true. Empty sequences are false. The test used in the example is a simple comparison. The standard comparison operators are written as same in many other languages, that is less than, for less than. We can also use a greater than symbol, or we can also use less than equal to, or we can use greater than equal to, or we can use equal to, or for not equal to, we use this. So these are the various standard comparison operators that we can use in Python. So over here, what is that is, for, let me show you the dry run. So I have two variables a and b. So initially, what the values of a and b are, a is first assigned to 0 and b is assigned to 1. Then what happens? Then we check a is less than 10. Yes, 0 is less than 10, true. So then we print a, so 0 gets printed, and then a and b are again assigned. Now what, a is assigned to b, So that means the new value of a is 1 because the value of b is 1, and the new value of b is a plus b, that is 0 plus 1, that's 1. So in the second run, so the initialization statement is executed only once. So now I'm in loop. So this time a 1 is less than 10, yes. So in that case, what happens? We will print a. See over here, 1 gets printed. So now since 1 gets printed, then again this assignment operation takes place. A is assigned to b, so new value of a is 1, and then b is assigned to a plus b. So at this stage the value of a and b is both 1 and 1, so summing them becomes 2. Then the same procedure, a 1 is less than 10, true. Then we are printing 1 again, and then we are assigning. So a becomes 2, and then b becomes 2 plus 1, 3. Similarly, next 2 is less than 10, the print happens, and then a is assigned to 3 and b is assigned to 5. Then again 3 is less than 10, so print happens. Then a is assigned to 5, b is 5 plus 3, 8. Then again 5 is less than 10, so print happens. A is assigned to 8, and then b is assigned to 8 plus 5 is 13. Now again 8 is less than 10, true. Then the last 8 prints, and now a is assigned to 13 and b is assigned to 13 plus 8, 21. Now while checking, is 13 less than 10? No, it breaks. So the pointer comes out of the loop, and now we have nothing more statements to execute. So the process finishes with exit code 0. So that was the basic Fibonacci series example that I've shown you. Now the body of the loop over here you get to see is indented. Indentation is a Python's way of grouping statements. Over here you get to see the gap, that is, it has been indented. At the interactive prompt, you have to type a tab or space for each indented line. In the last session that I've shown you, the interactive prompt, that is a Python command line over there. When you have to execute a loop, so once you print your loop's condition statement, and then when you press enter, then you have to give a tab for indentation to take place. When a compound statement is entered interactively, it must be followed by a blank line to indicate that the indentation is completed, since the cursor cannot guess when you have typed the last line. So now say over here, after this I have to press enter, and then I have to print a backspace to get out of the indentation to let the parser know that my indentation is complete. So now I can again start typing anything over here. So the print function writes the values of the argument it is given. Over there I have showed print a, so it prints the value of a every time it is being called. It differs from just writing the expression you want to write. In the early way, it handles multiple arguments, floating point quantities, and strings. Strings are printed without quotes, and a space is inserted between items, so you can format things nicely. So over here, if I print, I need to give an quotation mark, and then I can print as hello world. So when I run this loops gets printed along with this hello world, and see there are no quotes in the print statement. So when I'm printing a string, the interpreter knows that the quotes needs to be printed. Okay, so now I'll be showing you the if statement over here. So this is the code snippet from my cheat sheet. So over here what I've done is I've assigned a variable named as x to a value of 10, and then I'm checking if x is less than 0, I'm assigning x to 0, and I'm printing negative change to 0. So what happens is when the first checking takes place, if x is less than 0, then x will be assigned to 0, and then the print negative change to 0. That means any value less than 0 is in that scenario we are assigning x to 0 and printing that the value was negative and it has been changed to 0. Else if, this is elif is another word for else if. So for in elif condition, what I am checking is, if else if x is equal to 0, then I am printing x is 0. Or I am checking if else if x is equal to 1, then I am printing single. Otherwise I am printing more, or other than I can print as greater than 0. So let me run it. So see, my x is greater than 0. Now when I change it to -10 and then rerun, what happened is it was x value was negative and it has been changed to 0. And if I say it assign x to be 1, so and I run it, see, it says x is been single, so it falls under this condition. So this was about if and else if ladder of Python. So this if condition are basically this if else are basically condition checkers in Python, and we at quite times in our day-to-day programming life we find it necessary to check certain variables to meet certain conditions, and in such scenarios if else is one of the easiest way to check the situation. Now is one more new chapter, that's one more new instance, that is for statement. So here I have defined a list of words, that is Bella, Chow, and another is Bella Chow together. And then in this Python for statement iterates over the items of any sequence, that is a list or a string, in the order they appear in the sequence. So for that, what I have done is I am iterating over each word in the list of words, and I am printing each word and its length together. So am I good to go? I believe so. Let me do. So when I'm running, see, Bella is my first word, and the length of Bella is 5. Then the next word in the list is Chow. So this Chow again it gets printed along with the length, that is 4. And finally together Bella Chow comes and its length is 9. And I hope all of you are aware of Money Heist, one of the world famous TV series, and it's quite familiar, and I'm a big fan of it as well. So that's why you may find at many instances that I've used this term Bella Chow. Though I'm not bidding you farewell, but for the time being I'll just use those words. So what I meant is that this for loop is in Python is a strong tool for iterating over each element in a list. Now I'll be introducing you to the range function. Now what range function is, that when you try to iterate over a sequence of numbers, the built-in function range comes in handy. It generates numbers in arithmetic progression. AP. Remember those childhood APGP classes? Yeah, that's AP. So for I in range of 5, print I. Let's see what it does. Then let me explain. So see, starting from 0, it prints till 5. What it happens is it indexes starts from 0 until it and prints all the element to the element, the index that we have placed in here. So if we want to print the first 10 elements, so we should give the index field as 10 and then we'll print. So it will print starting from 0 to 9. That is because its index starts in Python, every indexing starts from 0, and over here 10 elements are there. So in the index field, placing 10 will give elements starting from 0 to 10 minus 1, that's 9. So over here what you have is for n in range of 2 to 10, then another new loop begins for x in range 2 to 10, and then I have a checking statement. If n modulus x equal to 0, then I am printing something, and then I am breaking out of the loop. This break statement acts for this inner loop. And then I have this else clause on loops. So what that is, so if the condition is not satisfied, means if this for is not executed, then else happens to take place. So what is that? So let me first explain to you. So this program basically finds out whether a number is a prime number or not. So for n in the range of 2 to 10, so the value of n varies from 2, 3, 4, 5, 6 in this manner till 10. And then for first operation, this is the dry run that I'm performing for you. So first time for x is in the range of 2 to 2, so that means there is nothing else to be executed. That's why it counts in the else section and says that 2 is a prime number. We will be going through the output as well. And then the next number is it doesn't enter the loop, and it falls in the x else section, and then the loop gets iterated again. So the next is n equal to 3. So for x in the range of 2 to 3, so here the values of x are 2 and 3, and then if n modulus x equal to 0, so 2 modulus 3 is equal to 0. So that means it says that n equals, so it does not fall into this region, and then it falls into the else clause on loop. So this else section and says that 3 is a prime number. And then what we have is for the next operation 4, the value of x will be 2 and 3. So 2 modulus 4 equal to 0. In that scenario, it says that 2 equals, the value of x will be 2 star n modulus 2, that's 2 into 2. And then the next one is so it prints and then it breaks from this inner loop. The next one that comes in the scenario is 5. The value of n becomes 5. Then the value of x will be 2, 3, and 4. So what happens is that because it ranges from 2 to n, so 2 modulus 5 equal to 0? No. Then it comes, then 3 more, then again this loop occurs. 3 modulus 5 equal to 0? No. 4 modulus 5 equal to 0? No. Then all the 3 condition doesn't happen, then it comes into the else section and says 5 is the prime number. In this format it goes on. So let me show you the output, then it will give a better picture of it. See, as I said, 2 is a prime number, 3 is a prime number, then 4 equals 2 star 2, then 5 also comes into this else section, 6 comes into, it does not come into else section because it says 6 equals 2 star 3, then 7 is a prime number, then 8 equals 2 star 4, 9 equals 3 star 3, blah blah blah. In that manner we check whether a number is a prime or not. So this is a beauty of Python that I always like about. The next section that we come into is defining function. Okay, so as I said earlier, what is a function? A function is a block of statements or a collection, a combination of multiple operations that are put together so that we do not, whenever in the later part of the code, whenever we require them, we need not rewrite them every time, so that we can reuse this block of code every time as required in the program. This keyword def, now over here, so this keyword def over here, it introduces a function definition. It must be followed by a function name, like over here as we have fig, and can have a set of parameters or arguments that it receives within this parenthesis. It may or may not, it's an option. The statement that forms the body of the function starts at the next line and must be intended. So after this colon, when we start the body of the function, so there should be an indentation, as I have earlier said. The first statement of the function body can optionally be a string literal. This
is what I am saying about. The string literal is the function's documentation string. It's a good coding practice to use this string literal to state to others that what this function specifically does. It's good practice to include a doc string in code that you write, so make a habit of it. The execution of a function introduces a new symbol table used for local variables of the function. All the local variables that we have used, when I call this function over here, as I am calling with the function name, and I am sending the value to this n, to this argument n that the function receives. So when I call the function, it introduces a new symbol table used for the local variables of the function. More precisely, all variable assignment in the function store the value in the local symbol table, whereas variable references first look in the local symbol table, then in the local symbol table of enclosure. The actual parameter, that is the arguments over here n, to a function call are introduced in the local symbol table of the called function when it is called. So when I'm over here calling the function, so in the local symbol table n gets initialized to 150. Thus, arguments are passed using call by value, where the value is always an object reference, not the value of the object. When a function calls another function, a new local symbol table is created for that call. Okay, so let me show you how this happens. So in this function, I have used the doc string that I was saying about, which describes, so it prints a Fibonacci series up to n. So we'll be checking that when so as I said earlier in the first example that I have shown here, where we are initializing a and b to 0 and 1, and then I'm checking when till a is less than n, I'm going to perform the operations of a Fibonacci series. So let me print when n is 150, so the till the sum turns up to 150. So these are the elements of the Fibonacci series, and I have called this function using this statement by the function name along with the value of the parameter that it accepts. So this function, as you saw, it does not return any value to the caller. But now let me show you another example that returns the value to the caller. So similarly over here, I have defined the fib function and the variable assignment as it is. The doc string also lies here. So over here, what I have added is a list named as result. So when over here I was printing those values, instead over here I'll be appending those values to this result list. Now when I call it, so suppose I'm calling it and the function fib and passing the value 150 to it, and I'm storing the value to a variable named as Fibonacci series. When I'm printing this variable Fibonacci series, you see you will get the same result as it's over here, but this time it's a list because from the function I have written a list. So when I've called this function, this variable is assigned to a list value and becomes a variable of type list. So that's why you get to see this list. So this was about the operational function, one which does not return but performs some task, and one which returns values to the caller function as well as performs some task. So whenever we need to call this function in our full process throughout, we can simply call this by their name. That means we are simply creating an object of that function. Now the keyword arguments of a function. So over here you get to see that this is a function named as parrot. What it accepts various parameters: voltage, a state, that an action. Means 4 parameters, 4 arguments. One is voltage, one is state, one is action, and one is type. And then I'm printing them, saying this in various formats. These are simple print statements where I am just putting the variables as and where. So now the first use case is calling the function parrot with one single argument, that is 1000. Now see, these variables are being initially assigned to some variables, but only this voltage is a parameter argument that receives some value. So when I run this, what you will see is that this parrot would not boom if you put 1000 volt. Where this 1000 comes from? Because I have sent this as the pass by value reference to this voltage. Over here, say I am printing action. Then the another this voltage is over here. Then this one type, we are printing the type, the northern blue, it's a stiff. All right. So the next is I am doing the same action by telling the caller function that which keyword to be assigned this value. So I'm specifying that voltage argument is need to be initialized to the value 1000. When I'm doing so, same it happens. So this parrot would not, what is the action? Boom. If you put 1000 over here, the voltage 1000 volts through it. So that's the use case of that. Over you can get to see that I've used a keyword end equal to space. That means for every print statement, it ends the statement with a new line by default. But if I explicitly specify that the end should be an space instead of over here, you can specify as end underscore end, space underscore space. You can also sorry, I've debugged it. So instead you can also when you run, see, you will get as end underscore end, and if you don't, as in these cases, you will get a new line to start with. So this was another type of function calling. Now when I'm calling the function and I'm then specifying the action as well. So I am now passing two values of two arguments. One is voltage and another is action. So I'm saying right now the action gets substituted to the value that I have passed, boom, and not the value that it is initialized to. Similarly, I can just alter that whether action or the voltage, the position, it doesn't change anything at all, because as long as the argument name is specified. So over here it will search from this list of possible arguments and assign the value as an applicable. So over here what I am doing is I am calling the function with 3 position arguments, but I am not stating what to do. Let's see what it does. What this is, the parameter would not, action is boom, but over here I have passed the action to be jump. So the parrot would not jump. If you put, then the first value is voltage, over here a million. So a million volt through it. Lovely plume, the Norwegian, the type I have not specified, 012, but type is at index 3. So I have not specified the value of the type. So it remains the same, the default one that I have initialized, the Norwegian blue. And finally, it says it's bereft of life. So it's from here, the value that I have passed. So now I'm doing this is that I'm passing the value of voltage to be 1000 and changing the state to be pushing up in the diasis. So what I've done, it remains the same. If you don't put 1000 that I've passed from here, and the state changes to pushing up the diasis. So that's how you can call the function, same function, in various kind of ways. Then finally, to the last segment of this session, it comes to the lambda function. So what this lambda does, sorry, I should not be uncommenting this, I should be uncommenting this. What is lambda does? Lambda function is a small anonymous function, and it can be created with the lambda keyword. This function returns the sum of its arguments. Lambda function can be used whenever function objects are required. These are syntactically restricted to a single expression. like nested function definitions, Lambda function can reference variables from the containing scope. Over here, you get to see is that I have defined three local variables a, b, and c, and the action they are performing is they will return a plus b plus c to the caller variable, that is x. So x is my lambda function, and now when I have called x as 5, 6, and 2, and when I'm printing that using this call, when I run it, so see 5 plus 6 is 11 plus 2 is 13. So that's all for today's session. Thank you. Have a great day.